Hi everyone. So next we want to discuss support vector regression. So support vector machine has a version of regression analysis that is support vector regression. So suppose that the x is a predictor and y is a response. So y is now continuous scale. Then in the same way as support vector machine, that we think about feature map phi that is from Rp to Rm. Typically, m is much larger than p. Then we want to use this feature map to do regression for these observations. So basically, we consider a linear model, but the phi of x is in a feature space, so it's higher dimension than p. And support vector regression has some special treatment on error. In linear regression, we minimize the sum of squared residuals. But support vector machine has different error function. So support vector machine minimize this error size and the size of parameter. So remember that the first part is error and the second part is complexity. So we optimize between smaller error and smaller, simpler model. And here, lambda is hyperparameter, so you have to optimize this in some way, such as cross-validation. Okay, so what is the error function v? So error function is the squared function for a linear model, but for support vector machine, the v of z is defined as this function. So v of z is 0 if the absolute value of z is less than epsilon. So that means if error is small, we don't penalize it. But if error is larger than epsilon, we penalize it linearly. So you can see the graph in the next page. So this function of v of z. So if error is small, z is error. If error is small, we don't penalize at all. But error becomes larger than epsilon or smaller than negative epsilon, we penalize it. So green one is the usual error function for linear regression. So support vector machine has different error function. What is the idea behind this error function? So that is in the next page. So basically, we can ignore the small errors in support vector machines. So that means if we have many observations here, basically errors are less than this bandwidth. So these observations are largely ignored. But if we have larger error, such as here or here or here or here, so these counts. So that means relatively small number of observations determine this fitted line. So that makes this curve the simpler than more data-oriented methods such as local regression. So this is the idea of support vector regression. Okay, so finally we have just one remark for both support vector machine and support vector regression. So that is about feature maps and kernels. So in support vector machine or support vector regression, we have thought about phi. But actually, the phi is not explicitly defined in practice. Instead, we define this k. K is basically an inner product in this space Rp. And k of x tilde is defined as the inner product of phi of x and the phi of x tilde. And actually, all algorithm works only with k. So we don't have to explicitly think about the phi of x. Okay, so now we finish this support vector machine chapter. So you can do quiz 26 3. 326 3. Okay, see you then.